Welcome to Maths and Science by IITian channel. In this lecture, I will be taking up a lecture on fundamental equation in thermodynamics. This is the basis for the total thermodynamics science, thermal physics. Rather, it is the basis for fundamental equation for understanding the thermodynamics properly. And it's in the differential form. And in the last lecture, I have shown you in the lecture number 7 what are the state functions and what are the path functions. Here, this fundamental equation of thermodynamics is written in the form of the state functions, where U is the internal energy, S is the entropy, V is the volume, and N is the number of particles. And when dou U by dou S is the partial differentiation, dou U by dou V is partial differentiation, dou U by dou N is partial differentiation. Whereas du is exact differential quantity, whereas ds, dv, dn are exact differentiations. These are partial differentiations, dou U by dou S. Now, we'll move further how it is going to help us in defining other properties and also in formulation of the various processes. For example, isothermal means temperature should be constant. Isochoric means volume should be constant. That means this particular value will be constant. What happens to other values in the equation? Let us see now, and let us see under various processes how this equation is going to help us to define the thermodynamic processes and how we will be able to develop the equations and develop the graphs, develop the plots. This is a very important lecture. Please listen to it till the end. Now, let's move further. What is the fundamental equation of thermodynamics? Fundamental equation of thermodynamics. It says du is equal to exact differentiation of internal energy is equal to partial differentiation of internal energy with respect to entropy into ds plus partial differentiation of internal energy with respect to volume into dV plus partial differentiation of internal energy with respect to number of particles into dN. And when these are done, which are the other things we are going to take as constants? You know that internal energy is a function of S, V, and N. Internal energy is a function of entropy, volume, and number of particles. Now in the first part, that is dou U by dou S into ds. Here, what are the other things constant? I will write in the another ink, that is V and N are constant here. In dou U by dou V into dV, in that what are the other things constant? S and N are constant. Entropy and number of particles. And dou U by dou N, That means we are differentiating means n is a variable. Other two are constants. That is SV or constant. This is the main equation, fundamental equation of thermodynamics. And internal energy is a function of SVN. U is equal to function of SVN. This is also a very important thing which you have to remember. Now, in this, SVN are independent variables because they are variables. Dou E by dou S. That means entropy is a variable. And dou E by dou V. Volume is a variable. Dou E by dou N. Number of particles is variable. That means SVN are independent variables. What is S? S is equal to entropy. Please remember this. U is equal to internal energy. V is equal to volume. N is equal to number of particles or moles, whatever you call, as per the convenience. Very important. And U is equal to function of SVN. This is also very important. Now, let us try to understand what is the first term. Du is equal to dou U by dou S into ds. What is the meaning of it? What is the meaning of dou U by dou S into ds when S is taken as a variable, V and N are constants? What is its meaning? Each term meaning, let us try to understand. This is a derived state function from SVN. Then what is its value? That is the question. Here we are required to understand dou U by dou S when volume and number of particles is constant is equal to what? From the first law of thermodynamics, what it is? From the first law of thermodynamics, we can say du is equal to delta Q plus delta W if the process heat is reversible. And from entropy definition, what is the entropy definition? ds is equal to delta Q by T, where Q is reversible process. Here dou U by dou S, where volume and number of particles are constant, which this implies this particular equation T ds is equal to delta Q reversible. This represents T is equal to delta Q reversible by ds. Are you able to follow this? Please try to follow them. Now, du is nothing but delta Q reversible plus delta W. You just see link. From definitions we are deriving. Du is equal to delta Q reversible plus difference between delta non-exact differential and exact differential I have already explained in the previous class. Delta W and T is equal to delta Q reversible by ds. From these two, we get dou U by dou S. When volume and number of particles are constant, it is going to represent T. The temperature from the fundamental equation of thermodynamics is represented like this. That means the temperature is nothing but change of internal energy with respect to change in the with respect to entropy. We are giving a excellent definition for temperature. That temperature is equal to dou U by dou S at constant volume and number of particles. Temperature is connected to change of internal energy with respect to entropy, and volume and number of particles are constant. This is the physical meaning of the first term. Now, let's go to the second term. What is that second term? Dou U by dou V into dV. What is second term? Dou U by dou V into dV is equal to what? What are the other elements constant? Yes, entropy is constant and number of particles is constant. Volume is changing. When you keep the entropy constant, not entropy constant, and when you change the volume, it is called as isentropic. This is S and N are constants. That implies entropy is constant. Entropy constant means isentropic. Isentropic means it is a adiabatic. It can be adiabatic. Let us consider adiabatic reversible process. We are considering all processes as reversible for simplicity. We are not taking care of any irreversibilities. But this particular equation is applicable for both reversible and irreversible processes also. Please make a note of it. The fundamental equation of thermodynamics is applicable for both reversible and irreversible processes also. Now, we know when isentropic adiabatic process in PV system, it is like this. This is P, this is P, y-axis. I have explained you already. This is V, this is point 1, this is point 2, V1, V2, this is point P1, this is P2, this is V1 and this is V2. V1 and V2. And we have already calculated work done in this. What is work done? Work done cannot be expressed in exact differential because it is a path function. Hence, it can be written as delta W is equal to minus P dV, which I have already introduced to you in the previous classes. For a reversible compression or expansion. Then from this end, dou U by dou V. Du you already know. Du is equal to delta W plus delta H. From the above two equations, we can safely write dou U by dou V when S and N are constants will be equal to minus P. Are you able to follow? Because minus PdV is the mechanical work done by the system on the surroundings. Next, let's go to the third term. What is the third term? Dou U by dou N into dN. Third term is dou U by dou N into dN when S and V are constants. Is it correct? Just check up. Now, what is the meaning of it? When entropy is constant, S is constant and volume is constant, from the definition of the chemical potential, that is equal to mu is equal to dou U by dou N. From definition it is Sn. It is energy change due to mass transfer. It is due to mass transfer. When you deal with the problems of mass transfer only, this equation is relevant. If mass transfer is not taking place, then this particular relation, third relation, can be neglected. But to cover all the possible energy transfers, the fundamental equation du is equal to dou u by dou s into ds. Others are constants. Dou u by dou v into dv plus dou u by dou n into dn. This is equal to du is equal to dou u by dou s is T. This is temperature. And this is dou u by dou v is equal to P minus P. And dou u by dou n is equal to mu. That means this can be written as T into ds minus P into dv plus mu into dn. This is the final meaning of the fundamental equation of thermodynamics. It's a very, very important equation. In this TDS is heat energy. This relates to work energy. This relates to mass transfer. That means change in internal energy will have heat minus work, heat plus work. It can be minus PdV is a work. Heat plus work plus mass transfer. Mass transfer energy. That means change in internal energy from first fundamental equation of thermodynamics is defined as change in internal energy is equal to change in heat energy plus change in mechanical energy, that is my work energy, plus change in mass energy, mass transfer energy, that is mu into dn. This is very, very important. Once we understand this, now, for example, if I take mass transfer as 0, if I say mu dn is equal to 0, what happens? For simplification purpose, du is equal to Tds minus Pdv. Are you able to follow? Which is nothing but du is equal to, sorry, we will use the different pen. Du is equal to delta H plus delta W. This is the first law of thermodynamics. We got first law of thermodynamics from the basics of the fundamental equation of thermodynamics. When there is no work done, the total work done is not there, then this becomes 0. What happens then? du is equal to TdS. From these two, and du is equal to delta H plus delta W. We can call it as H or delta Q, let us say. Delta Q reversible plus delta W. That means we got two equations here. When PDV work is not there, du is equal to two equations, please remember them, minus PDV when number of particles are not there, mass transfer is not there. This is the controlling equation. Second controlling equation is du is equal to delta Q plus delta W. These two are the controlling equations, and if PDV is equal to 0, that implies du is equal to TdS, and du is equal to delta Q reversible. That means TdS is equal to delta Q reversible. That implies temperature is equal to delta Q reversible by ds. This is another important equation. These are all interrelated, these equations, and these are very, very important equations which we will be applying in different processes. Let us consider, for example, reversible adiabatic process. Reversible adiabatic process. In this, what happens? There is no heat exchange. What is du? du is equal to TdS minus PDV. That implies when there is no heat change, when it is 0, TdS is nothing but Q reversible. This is Q reversible. This is equal to 0. There is no heat change. Then du is equal to minus PDV. du is equal to minus PDV. That is equal to work done, because heat exchange is not there. That implies W is equal to dW. It is delta W, or rather I can even write it as delta W. That means change in internal energy itself is the work done. Delta W minus PDV. Then W is equal to change in work done is equal to from point 1 to point 2 minus P dV. And if PV is equal to constant, we have done the problems. In this, we have calculated the work done also by using this equation. The relation between P and V. For example, P V to the power of n is equal to constant. That implies P is equal to some constant by V to the power of n. That implies work done is equal to minus integral 1 to 2 C by V to the power of n dV. That V can be 1, V can be 1.5, V can be 1.4, that can be V to the power of gamma also. This is where adiabatic. What we are talking about? Reversible adiabatic process. This integral can be easily calculated. There is nothing what you call rocket science in it. We can say work done is equal to minus integral 1 to 2 C into V to the power of minus n dV, that is equal to integral x to the power of n is equal to x to the power of n plus 1 by n plus 1, that is equal to minus C into V to the power of minus n plus 1 divided by minus n plus 1 under the boundaries 1 to 2. Rather, we can say V1 to V2. Therefore, work done is equal to minus C into V2 to the power of 1 minus n minus V1 to the power of 1 minus n whole divided by 1 minus n. This equation we have already used in the previous calculations. It's a very simple to derive it when you know. This minus C is from the PV to the power of n. What is the constant value? That from the given conditions we can definitely come to know. That how to find out the constant value also I have explained in the problem. Please see that video. Now, next is isothermal process. How you define using this fundamental thermodynamic equation. What is a fundamental thermodynamic equation? Thermodynamics equation du is equal to TdS minus P dV. Here I am not taking mass transfer. I have neglected. Now, when isothermal means T is equal to constant. Du is equal to TdS minus P dV. For an ideal gas, internal energy is the function of temperature. For an ideal gas, which implies when temperature is constant, du is equal to 0 when temperature is constant, as dt is equal to 0. Hence, the equation du is equal to TdS minus PdV becomes 0 is equal to TdS minus PdV. That implies TdS is equal to PdV. That implies P by T is equal to ds by dV. It's a very important for isothermal process when temperature is constant. From these we will draw the graphs. In the next class I am going to draw the graphs for PV, TS and all those. Sir, these are the basic foundations which you should know. P by T is equal to ds by dv. But for a ideal gas, PV is equal to nRT. That you are already aware. That means P is equal to nRT by V. That means we will replace P value here. P by T is equal to nRT divided by V divided by T is equal to ds by dv. That implies gets cancelled. ds is equal to nr into dv by v. This is another important equation. Then, when you integrate it between V1 and V2, we will get change in entropy. And another thing also, TDS is equal to PdV. We will replace this here. If the process is reversible, as we are dealing with without reversibilities in our total course, as the isothermal reversible process, Q reversible is equal to TDS. Because we have assumed change in internal energy is equal to 0, since 0 is equal to TDS minus PdV, and Q reversible is equal to TDS This implies Q reversible is equal to TDS, that is equal to PdV, because it's a reversible isothermal process, that is equal to integral V1 to V2. What is the value of P? nRT by V. nRT by V dV. That is equal to nRT, because temperature is constant, this can be a constant, integral V1 to V2 1 by V dV. That implies Q reversible is equal to nRT into ln. 1 by V dV is nothing but logarithmic. Log V. Log V means log V2 minus log V. Log V2 minus log V1 is log V2 by V1. ln. Natural logarithm if you take ln by ln V2 by V1. That means from the equation of because du is equal to TdS minus PdV in isothermal process, because internal energy is equal to 0, 0 is equal to TdS minus PdV. That implies TdS is equal to PdV, and that implies Q reversible is equal to total Q reversible is equal to W is equal to nRT into ln V2 by V1. Now, let us consider a process isochoric. Isochoric process, what happens? Volume is constant. Next is isochoric. du is equal to TdS minus PdV. This much we have got already. In this, V is equal to constant. That implies dV is equal to 0. That means work done is 0. That means du is equal to TdS. For an ideal gas, du is equal to Cv into dt, because U is equal to function of temperature. Internal energy is equal to. This is very important. Cv is specific heat at constant volume. Molar heat capacity. Cv is equal to molar heat capacity. It implies du is nothing but delta QV at constant volume. This is nothing but delta Q. That is equal to du is equal to if N is the number of moles. It is molar heat capacity per mole. This is N into Cv into dt for N moles. That means for isochoric process, because of the internal energy change, there is no mechanical work done. Heat is added. That means here dV is equal to 0, du is equal to TdS. What we have got here? Work done is equal to 0 because dV is 0, and heat delta Q is equal to du is equal to, because that is change in internal energy, work done is 0, N into Cv into dt. These are the equations derived from the fundamental equation of thermodynamics. Now, isobaric. Can we derive it? What is our fundamental equation? Let us remind again. du is equal to TdS minus PdV. From this only we are deriving everything by taking mass transfer as neglected. Here du is equal to, now here we will write heading as isobaric process. Isobaric process. In isobaric process, dP is equal to 0. What is our equation? du is equal to TdS minus PdV. Now, to understand the isobaric process, we will go to the definition of enthalpy. Enthalpy is equal to H. Enthalpy H is equal to U plus PV. Internal energy plus work. PV is nothing but work. U plus PV is the internal energy. Internal energy plus work. This is the enthalpy. Now, when you take the differentiation, dH is equal to du plus d of PV. When you take d of uv, two functions, u dash v plus v dash u, from your preliminary calculus you may be knowing, product of differentiation of product. Then this will become du plus dp into v plus dv into p. That implies dH is equal to du plus dp, because p is constant, dp is 0. 0 into v plus p into dv. That is equal to du plus pdv. Are you able to understand? du plus pdv is nothing but TdS. Therefore, dH is equal to TdS. Change in enthalpy is equal to temperature into change in entropy. When dP is equal to 0. From enthalpy and entropy, we will be able to understand the isobaric process. For an ideal gas, everything we are doing with respect to our fundamental equation of thermodynamics. du is equal to NCV dt, which we have done already. dH is equal to NCP dt, because we have kept pressure as constant. And from these two, Cp and Cv are defined, and Cp plus Cv is equal to R, universal gas constant, for an ideal gas. This is for an ideal gas, we are doing it. Heat at constant pressure is equal to NCP into dt is T2 minus T1. This is one equation. Internal energy. Change in internal energy. Delta U is equal to NCV into T2 minus T1. You please see how equations are developing. And dH is equal to TDS. All these equations we will be using in the examples. Work done on the system is equal to minus NR into T2 minus T1. Because that is equal to minus P into delta V. Entropy change. Delta S is equal to integral T1 to T2 Cp by T and dt. Because dH is NCP dt. In place of dH, when you put NCP dt, then you will get delta S, NCP dt by T. Because here it is dH is equal to NCP dt. Then it will be Cp by T into N dt. That implies delta S, change in entropy, is equal to NCP ln T2 by T1. This is the isobaric process. And we will have different process diagrams, PV, PT, TS, BT. All these process diagrams we will be discussing in the next class along with the plots. Mainly using the concepts what we have developed from fundamental thermodynamics equation. Fundamental thermodynamics equation. You please see that this equation is dou u by dou s into ds plus dou u by dou v into dv plus dou u by dou n into dn. If mass transfer is 0, if dn is equal to 0, that implies du is equal to dou u by dou s into ds plus dou u by dou v into dv. That implies du is equal to tds minus pdv. This is the most important equation. Simplified fundamental equation of thermodynamics. On the basis of this, we got all the other equations for different processes. And with this, I want to conclude this lecture. Best of luck to everybody. Thank you for listening to me. Thank you for viewing my lecture. If there is a value addition because of this lecture to you, kindly hype this lecture kindly share this lecture and kindly subscribe to my channel Maths and Science by IITian. Thank you. Best of luck.